What's going on, everyone? So I wanted to cover some quick notes on this week's material. So we kind of get back into the software development of the of our concepts. So let's take a look at a few of these things. So this revisits our software development lifecycle, and specifically we're at segment 4 of that software development lifecycle, and you'll see that each segment, as we've discussed, has subsegments beneath. So let's look at what's going on in segment 4. So in this segment, we need to clarify some details of our project. We're going to make sure that we understand what the objectives are of the stakeholders, specifically the customer and what the customer needs. Now, again, these requirements change pretty rapidly. So, in a software development life cycle like Agile, for instance, Agile pushes information out or pushes products out really quickly and then modifies those based on those evolving requirements. We need to make sure that we understand what the desired output is going to be, as well as the required input. Now, this is important because we'll see a little later that as we get into our modular design, each module or each submodule or sub-program in our code is potentially going to be assigned to specific software teams. So you'll have one team that is going to be working on a subcomponent of our overall application. So that subcomponent is going to have a desired output. It's going to be clearly defined what that output is going to be, and to achieve that output, the developers are going to be given what input is going to be coming into that module, if any at all. So, of course, to achieve that desired output, we need to define what the necessary processing is going to be, and double check all those details. And inside the code that we are responsible for, make sure that we document what's going on in the code. And this is important, once again, for if we work on this code and then 2 years later we go back to revisit that code and make modifications to satisfy customer requirements, or more importantly, if we're no longer part of that software development team and that piece of software goes to another software development team, they need to understand your line of thought when they go to make modifications to that code. So, structured programming, we're going to be using a top-down program design, and that means that we've talked about this before, we start with the main problem, or what the desired output is going to be, and then break that down into individual problems so we can break that into modules to satisfy the end result. And of course, we're going to use pseudocode to demonstrate our algorithm, and that's prior to writing the higher level language. And we're also going to use flowcharts to capture the processing flow and what's actually happening in the program. And once again, those flowcharts, the blocks in those flowcharts do not necessarily match the number of modules that we have in our code. For instance, if we are a software team working on one specific module, that module is going to have a flowchart all its own. So we need to be careful of that. So, of course, when we get to the coding portion of this, we convert that pseudocode to a higher level language, and that's one of the reasons that we use pseudocode, is so that that pseudocode can be translated into whatever programming language that we're going to use. And now you guys will learn later on what programming languages are best to suit specific problems, because some are designed better for scientific algorithms, some are better for accessing databases and extracting data from databases or inputting data in databases and things like that. But you'll guys pick that up a little later on as you start studying these higher level languages. And make sure that you use the proper syntax regardless of the language. And now the syntax includes the proper command structure and so on and so forth, but it's also very important to make sure that you have proper formatting to include the indentation where the indentation is needed and so forth, so the readability of the code is a little higher. And of course, you need to test the code once you get the program written. And now, again, as we've broken up into software development teams, and each team is responsible for specific modules, they will be able to do what's called node testing, and they'll be able to input their values into their code and make sure that it has the proper values coming back out of their code. And they'll debug that code accordingly based on those test results. And then once we test by module, then we'll start putting those modules together in a full program, and then we will test that code with real-world data. Now we have to be very careful about that, because in most cases that code is being tested with real-world values, though it's not in the production environment. In other words, it's not processing data that is being used in the production environment or being used by the customer. We want to make sure that our code is 100% capable prior to going into the production environment. Documentation, I know that I've stressed this a million times before. Documentation is so very important. Now, the external documentation is the user documentation that, for instance, that you might get with Microsoft Office, and operator documentation is for more advanced applications that are used in an operator environment. For instance, an air traffic controller has software that they use to manage air traffic. They need to know how that software is used to do their job properly. And then, of course, internal documentation is the comments within your code to define precisely what's going on in your code. And then, of course, that documentation within the code is used later for code maintenance. So once again, this is just a bit of review of information we covered in the first couple of weeks. Machine language, of course, is ones and zeros. That's what goes through the processor to tell the processor and everything in that CPU what to do. And then assembly language is a programming language that goes directly from the assembly into machine language. It's a one-for-one type language, which means that one command does one specific task. And then you have your higher level language, such as C or C++ or Java, and C++ and Java, of course, are both object-oriented programming, where C is not. So, and again, you guys will get more into that later on when you get into your higher level language. And then the very high level languages are problem-oriented. Like, for instance, SQL is a very high level language which focuses precisely on database manipulation or database creation. And then, of course, natural languages is this is the spoken word. So I wanted to touch on more on our modular design real quick, because what we've talked about thus far has been modules within a single program. But now, as you guys move into those higher level languages like C++ and Java, you will see that there are sub-programs as well. And those subprograms are handled a little differently, or actually quite a bit differently, in terms of variables and how variables are used. So we'll take a look at that here in just a second. So, and again, each subprogram is potentially developed by an individual team. So let's take a look at that real quick and demonstrate how that what the difference is between the submodules and the subprograms. Okay, so if you remember, this was from assignment 2. We have a main module and then modules beneath the main module. So and all of this is part of an individual program. So so as we declare our variables, these variables are considered global, which means that this variable can be seen by all the modules beneath, and that's regardless of where they're used. Now, of course, you need to be careful about that, because if you declare a variable in the main module and then you modify its value in one of the submodules, there's only one memory location for that variable. So if you modify it in the submodule for choose case and then try and access that again in perform calculations, then you need to understand that the modification that you make on that variable in the first submodule is going to be exactly what that value is when you access it later. So let's look at now. This is a very simple demonstration of a subprogram. So we have our main program, and now you'll notice that that I no longer have main module, because this block from here to here is a program in its own. So now we declare a variable called my number and set that as an integer. We declare that as an integer. So that grabs a block of memory that that defines that data type as an integer, and then we set the value of that variable called my number to a value of 6754, and then we call the subprogram any sub. And now notice this is not a submodule any longer. This is a subprogram. So when we get down here, we can declare another variable called my number, and notice that this variable name is the same as this variable name. However, since this is a subprogram, we grab a new memory block, and we define that as an integer value, and then we declare another variable called your number, and declare that as an integer. And now notice what happens. In the main program, we have set this variable, my number, to 6754, and then down here we set my number is equal to 2. But now remember, these are two different memory locations. So so this variable is set to 6754 and this variable is set to 2, and then when you set the other variable, your number equals my number times 3, then it multiplies 2 times 3 and puts that in the variable my number, and then it says write your number. So of course that's going to output 6 as demonstrated right here. So now notice what happens when it leaves this subprogram. It goes back up here to this location and goes to the next line, and instructs the processor to write my number, or write the contents of the variable called my number. So of course it's going to access the variable that was defined in main, which contains 6754, and output that display, or output that value to display. Okay, so let's take a look at how we can manipulate those variable values between programs. So we'll kind of take what we had as our original program and use that here. So again, we are declaring a variable as an integer called my number, and that grabs a piece of memory and defines that as an integer data type. There's no value in there at this point. It's just defining that as an integer data type. So we set that location or that variable contents to 7654, and then notice what happens. Excuse me. We call our subprogram AnySub, and we pass the value of that variable to that subprogram. So we get to the subprogram, and notice that this variable name doesn't match this variable name. Now, don't be confused by that, because both of these names are pointing to the same memory location. They just have different labels. So that memory location now has the label or variable name my number, and it also has the label old number. So, but don't let that confuse you. Make sure that you keep your brain wrapped around the idea that these are pointing to the same memory location. So we get to this subprogram, and now this is effectively declaring a new variable name for the same memory location. So we declare a new variable location, name your number, as an integer value, and then we set your number variable, that the contents of that memory location, to old number times 3. So that's going to be 7654 times 3, which is going to be down here when we write your number, it's going to be 22,962. And then at that point, we're going to go back to this location, and it's going to output my number. And now the value of my number has not changed at all, right? So it's going to output 6754. So we'll get into that a little bit more later in the class, but not too much now. But I wanted to bring that to your attention as you start getting into the higher level languages. It's really, really important to understand how those variables work. So keep an eye on that, and that's all I've got for this week's information. So again, if you have any questions at all, please let me know. Either drop me a line by email or drop a comment in the questions and concerns area for this week. Thank you very much.